Okay, we've been talking about congruent shapes, which have the same size and same shape. Okay, they're the same size and the same shape. Today we're going to switch gears just slightly to similar figures. Okay, so what that does is it's a sequence of transformations, and now we're adding in dilation. So if you look at your triangles here, what do you notice is the difference? The size. Okay, so if we dilate, we make something what? Bigger or smaller. So that is going to be part of our process today. Looking at example 1, I want to go from the smaller figure to the larger figure. Actually, just kidding. Let's go from the larger figure to the smaller figure. So the green to the blue. When we write ratios, ratios can also be written as fractions. Okay, they're looking at sides here. So D and E correspond with what other side? H and G. Okay, now HG, if you count those units, you should get 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, which is where they got this. DE or ED is 1, 2, 3, 4. When we simplify, we get 2 over 1. What does that simplify to? 2 over 1. It's 2 whole things. Okay, any whole number is over 1. When we find similar figures, you only have to compare 2 sides. So what's my other side that's easy to compare? My hypotenuse or my base? Your base. So G and I and DF. So GI is 1, 2, 3, 4, 5, 6. And DF is 3. When I simplify 6/3, I get 2 over 1, which simplifies to 2. Are these matching? Does 2 equal 2? Yeah, so they're equivalent, which means that they are similar figures. Okay? Now, if they are similar figures, you have to tell me how I get it to match, just like we were doing. So what would I do with triangle DEF there to get it to match GHI?
Scale it down to.
I'm not going to scale it.
Dilate it down to.
I want the blue to the green.
You're going to dilate it up to.
Okay, so if I dilate it, my scale factor is 2, because that was my ratio. Does that get it right on top of my green triangle? So what should I do first? I would translate. So we're going to translate to the right how many units? 1, 2, 3, 4, 5. And does that get D and G matching there?
Well, not matching.
No, so what do I have to do after I translate to the right 5? Down 2. Then you can dilate using your scale factor of 2. That make sense? Questions? Okay, let's go down and look at the second example. Now we have rectangles.
24 and 30.
Good. And then, Brianna, what did you scale factor it by?
Using 2 sides, does it make sense if I were to use this side, this side, this side, and this side? Are those the 2 sides you would pick to compare?
What did you get?
I would not. Why wouldn't you?
Because the bases have a small.
Okay.
Yeah, these are essentially the same sides, right? They're the same length. So you're going to want, lack of better terms, a long side and a short side. You want the different sides, okay? So between U and V, what is that going to correspond with on my green triangle? UV.
Like X and Y.
I didn't do it that exact way.
Well, UV is a long one, so X and W is short. I know that's not going to work.
I got
X and Y.
X and Y and W and Z, those are the same sides. I want something to what corresponds with U and V? Z and W. Yep, if I rotate this, Z and W. Okay, what sides correspond with TU? ZY. So I would use those two sides to compare, which they have here. If we do
I want you to do
TU and YZ, 1, 2, 3 is TU. YZ is 1, 2, 3, 4. UV is 1, 2, 3, 4, 5. And ZW 1, 2, 3, 4, 5, 6, 7. Do 5/7 and 3/4 equal? Are they the same ratio?
No.
No. So are they similar figures? No. Questions with that? All right, let's look at got it A.
What are we doing?
Now, it doesn't matter if you go from large to small or small to large. You just have to stay consistent, writing your ratios. So let's do one way and one the other here. Looking at our triangles, what sides would I pick to use? I need two sides. What are the best ones? P and Q and Q and R. Yeah, because I can just count my units. So what sides do they correspond with? What does PQ correspond with? S and T. And then QR corresponds with TU. So go ahead and set up your ratios. Let's go from small to large. So the blue to the green there. All right, so ST, what's my measurement of ST? 3 over, what's PQ? 6. Simplifies to 1/2. Okay, UT and RQ, what's UT? And RQ? Simplifies to? Are these equal ratios? So are they similar figures? Yes. So since they're similar figures, how would I move my blue triangle to my green triangle so they match? Okay, so we can reflect over what?
Y.
Reflect over Y.
We're getting blue to green, right?
Blue to green, yeah? Then what do you need to do?
You're gonna want to translate it right.
So essentially this would be my Y. So if I'm one away, it's right already there.
Okay.
Then we're going to dilate. Oops, dilate. Can't write and talk at the same time. Using a scale factor of what? Units. So if I would have gone big to small, what would my scale factor have been? Instead of 1/2, it would have been 2 over 1, which simplifies to 2. So you could have done the same thing, just use the scale factor of 2. Just so you see that. Questions? All right, let's go ahead and work B. You can decide if you want to go large to small or small to large here. Remember, we have to pick two sides that are easy to find the measurements of. So I picked AB and EF. What's our side length of AB?
So do I just multiply one side by 3?
3. And EF?
2.
So then it would be what?
4.
Okay.
Then I have
AD. What's my length of AD? 5. And EH?
So then what do you get for 4?
Are these equal ratios?
And what would the label be?
No. So are they similar figures? So do I have to move my shape to get it to match? No, because it never would match no matter what I did. Questions on that?